Hello everyone, and thank you for subscribing to Infoverse Tech. As most of you are aware, we create tutorials in leading technologies like artificial intelligence, machine learning, Python programming, cloud computing, and similar. It's been a while since I posted some videos. Been extremely busy, but I promised to create more content, content that people can learn from, people can apply to their jobs or their work. And today we're going to look at something simple, which is a Python list. However, it's an extremely powerful concept. Python lists are just like dynamically sized arrays. Example, it's called vector in C++ or an array list in Java and similar. In very simple terms, a list is a collection of things enclosed in square brackets and separated by commas. We're going to look at a number of different examples, look at what kind of elements can be put inside a list, how you can mix them, and so on. Lists are the simplest containers that are an integral part of the Python language. A single list may contain different data types, including integers, strings, as well as objects. And lists are mutable, which means that they can be changed, so they can be altered even after we've created them. They are used to store multiple items in a single variable, so I can say fruits, and then I can add different types of fruits inside that list, and they'll all be assigned to a single variable. So today we're going to cover Python lists, and in the following videos I will try to cover related to lists called tuples and sets and dictionary. So I'm here at the W3 schools page, and you can see there are some built-in methods that we can use and apply on arrays. So starting with append, clear, copy, count, extend, index, inserting an element, pop, remove, reverse, sort. So these are some of the built-in methods, and I'm going to cover all of these in our tutorial. So let's get started. As you are aware, I usually use Jupyter Notebook or VS Code. The reason for choosing Jupyter Notebook is that for a tutorial like this one, where I'm entering small commands showing what it does, it's easier to use Jupyter Notebook because I don't have to create a file. And then I can make changes and rerun it. So it's so much easier. But either VS Code or Jupyter Notebook, both are fantastic tools, and it's totally your preference which one you would like to use. So like I said, let's get started with the first example, and let me just pull up one. So I'm calling it, the list name is fruits, and as we can imagine, it contains a bunch of fruits. So let's run that, and now we have a list called fruits with some elements that are contained inside it. Similarly, I can create another one, call it numbers, and it has some bunch of numbers. So the name here is totally arbitrary. You can choose anything. It just helps to give it a name that reflects closely to what the contents, what elements it contain. And like we mentioned in the introduction, list can contain a mix of data types. So here we have something called alphanumeric. It's got a mix of some text, as well as you can see it's got some numbers as well. And I think the syntax is pretty clear. You have for the list, you have a square bracket starting, ending with a square bracket, and in between the elements they are spaced with a comma. If it's numbers, you don't need to add these commas, apostrophes, However, for text you have to enclose it like this. It can be a single apostrophe or two, both work. Here you can see I'm mixing both and works fine. And the way to print it or display the values of this list, I can simply type this and just run it, and it runs, right? I can also print it similarly. So extremely easy, different types, very easy syntax. And I said there are additional data types that we can add. So you can see I can also add Boolean here, and that's also acceptable. Okay, so as an example, let's talk about some of the properties. The list items are ordered. We'll see what they are ordered by. It's called an index. It usually starts at 0 and then 1, 2, 3. So those are how these elements are addressed. So it always starts with a 0. So they are ordered, the elements are changeable, and they allow duplicate values. So as an example, this numbers list, I can add numbers that are repeating, and that's perfectly fine. It will accept that. And if I run that again from here, you can see that it accepts that as a list. So let's look at some operations that we can do on a list. So sometimes we want to know the length of this of a list, right? So the way to do that is we just use a command called len, and I can just write it here. So if I want to find the total size of this list, call numbers, I can do print len for length, and then enclose the name of the list, and following two parentheses just to match the ones that we opened on the left hand side. And if I run this, it prints out 7. So 1, 2, 3, 4, 5, 6, 7. So do understand that this is the total number of elements inside this list, but if you were to address it, our index would reach only up to 6, because you will have 0, then 1, 2, 3, 4, 5, 6. So another thing to remember is that the index is always the length minus 1, and you'll see how you can use that in future when you're doing some programming. You can get the length of a list and then use that to either go through the list or use it in some other manner. So again, a very important concept. Let's see, we can use something called a max. So let me just print it here. So we want to find the maximum element in a list. If I run this here, so what we're doing is we're just assigning a new list called max list, entering some again some fruits, and we're saying print the max. So the keyword here is max. Find the maximum out of these text here. So when I run that, it actually prints pineapple. So as you can imagine, in alphabetically speaking, P is the last, so it considering it the highest or the maximum number out of this. We are mostly used to see maximum minimum in numbers, so let's have this example. So when you talk about maximum numbers in a list, you have this list, and when we run that with a print, so max and then the max list, and when I run this, I expect it to give me 99, which is correct. 99 is the largest or maximum number in this particular list. Let's say as example, I now have another number added here. When I rerun this, it automatically now understands that the maximum number has updated in the list. Similarly speaking, we can just also find the minimum number in a list. So if I just replace max with min and run it on the same list, let's see what we get. And as expected, we get a 1. Now let's see if we can add another number here, 0, or let's say a -1, and let's rerun that, and you can see that it understands new elements have been added, and when you're recalculating the minimum, it prints out the right number. Now we did say a number can appear many times in a certain list. So let's say we have 45 appearing maybe 45 times. Just kidding there. So let me give it one more time. So perhaps this is let's call it scores, right? And let me take these away. So let me make it something that resembles a score that's maybe in a class. So students are getting these scores, and some of them got 45. So what we want to find out is how many of those were like 45, right? So what we can use is something called count. So I'm going to use count scores dot count, and then inside here I want to which number I want to count for. So let's say I'm interested in 45. So when I run this, it prints 4, which is correct because we see 45 came 4 times in this list. Let's say I'm looking for 99. When I run that, as expected, I get 1, right? So this is the syntax, the name of the list dot count. So you're counting, and then you have to specify within these parentheses the element that you're looking for. Okay, let's list this, sort this list, right, in terms of ascending or descending. Now let me just pull up this little code here. We can even run it on this one. So if I write scores dot sort, and we run that, and then we say print scores, the name of the list, and you can see it made the right sorting from lowest to highest. Now when we run this without any flags or any switches, the default is ascending, and we can reverse this by adding if you wanted this to be in descending order, we can run this command, but here we just need to add a qualification to say that reverse is true. Let's run that, and when we run this, as you can see, we've changed the behavior. So by default, sort will do it ascending, and if we add this little switch here, it can sort the list in descending order. So good information to know when you're sorting lists. Let's take another example where we have something like this list is called places, and you have some countries here. We sort it and remember, we're not adding any qualifier here, so it's going to sort it in ascending order. So when we run this, you can see starting with the Antarctica, Canada, China. It's just using this the first letter to make that ascending. And if I add the reverse, you will see that I can reverse this list, and so it's descending order, and it does. Now there's another small idea where I can I'm not interested in sorting it, rather I just want to flip or reverse the, or let's say invert the list, right? So if I have this list here and let me run that, so it's just some list, right, starting Antarctica and Japan, Canada, and again you notice that it's now again not ascending or descending, right? It's just the original list. Now what I want to do is, when I use the other command, which is reverse, it will actually flip this. Here we see starting with Antarctica. When I run that command, it'll just, China will come first, then Kenya, and it'll be just backwards, right? So again, interesting. Let's see what the syntax is. So I can probably add it here, and that's why I love Jupyter Notebook for these kind of tutorials, because I can just go in place and make those changes and rerun it, and not have to worry about a file or updating a file. Okay, so if I say places dot, and the command is reverse, and just because it's like a function, so I don't need to give anything here. When I do that, remember it's just going to flip back. So right now it's starting Antarctica, Japan. The order will change, so it'll be backwards. So let's run that, and you can see it just basically flipped it, right? So understand the key difference between this one and the sorting. So we are also using reverse and sorting, but that sort is for ascending and descending, and here we are just taking that list and we are flipping it, right? So interesting concept, and a good good knowledge to have. Okay, let's look at some other examples. For example, we can make a list of make a copy of a list. So let me get an example here, demonstrate. So I have something called this list. It's got apple, banana, cherry, and then I can just do a my list equals this list dot copy. So all it's doing is it's just making a copy of this, the original, and storing it in a my list. And when I run that, my list contains exactly the same, so no surprises here, but we just made a quick copy. We can also make a copy using the list command. So if I bring the code here, so similar, it's the only thing is, instead of using the dot copy, we're using the function called list, and when I run that, you get basically the same result. Now let's look at how we can access those list elements. So remember, the list elements always start with 0. So this element here is, when you reference it, it's at 0. So the next one would be 1, 2, and then it increments in ones. So let's look at an example. Let me bring something here. So let's say this is a mixed list. We saw it earlier, which contains text as well as numbers as well as boolean. What I want to do is, I want to know what is at index 2. So remember, this apple is at index 0, banana is at index 1, and if I choose 2, I should get cherry. So let's write it down here. So I want to say print the name of the list, which is mixed list, and then I want to specify the index. So here I'm entering the index. So the syntax is to enclose it in the square brackets. So when I run that, what I'm essentially saying is that I want to see what you are storing, what mixed underscore list is storing at index or address number 2. So when I run that, as expected, we get cherry, because it is at index 2. and mango is at 3. Let me give you, if I want to see what is at index 3, so if I just replace this with 3, I should expect to get mango as an answer, and it does. Okay, now the interesting part starts. I would say most of the time we right now we're just for the sake of this tutorial, we're working with very small lists, so we can see this list has maybe 8 elements, another one had 3, another might have 20, so very small lists, right? But when you're writing a program or you're doing some real life application, you might not always know the size of the or the length of that list, so you need to use like the len command that we saw earlier to get a list or a total number of elements. And how would you get the last element as an example, right? So they have Python has a very smart way of doing that. So if I want to look at the last element, as I would not always know the size of the list, I can do print mixed list, that's the name of the, and then here in I would say -1. So when I say -1, it's automatically tells Python to go and fetch the last element, right? When I do that, so another way to do this is to get the length and then say length -1, and that will give you the index as well, right? So if I do the length of this this list, and when we run that we get 9, and then I can use I know that 9 is the total number of elements, so this last element would be 9 minus 1. So if I go here and I say 9 minus 1, or I can say 8, I should get false, right? Which is correct. Or I can just say 8. So you can use these methods, but sometimes you just want to quickly get it, so you can skip this finding the length first and then going back and doing some calculations. So it's a very smart and shortcut way to get the last element very quickly. Now Python also supports like finding a range of elements. So let's say, let me bring up the list, so mixed underscore list, and I want to find out from that list what is the element starting at, let's say, index 2 and all the way up to index 5 as an example, right? Now one thing to note is that it will start at index 2, but it will stop at 5 minus 1, or whatever is the last the number here, one less than that. So when we run that, so it starts with 2, which is 0, 1, 2. So it starts with cherry, and then it gets mango, which is 3, and then gets apple, which is 4, and then that prints it out, right? So 2 to 5. If I was to change that to, let's say, 6, and we run that, you see that it can go, which is the 5th element actually, and fetches that. Now if I was to leave out the first element, right? This is the syntax. So this is the first element, this is the last element. If I left out the first element, so mixed underscore list, and I would say I leave it blank and I say 4 as an example. What this will do is that if you leave out the start value, the range starts at the first item. So it automatically assumes that you want to include the first element, which is apple in our case. So when we run that, we get apple, which means it's took the 0 index and all the way to 4 minus 1, which is 3. So 0, 1, 2, 3. It prints out these. So again, shortcut way of just saying, get me the first four elements of a list. I just want to be faster in presenting that range. And if we leave out the end, it will automatically go to the end of the. So if I just flip this to, let's say, make this 4, and instead of 4 I have nothing, so Python knows that it wants it to start with whatever is at index 4 and go all the way to the end of the list. Again, very useful, because you might not know what is the size of the list. Might be 1000 elements. So when I run that, it starts with 4, which is 0, 1, 2, 3. So fourth item. Actually, it's a little confusing because you have at index 4 and you also have Apple at index 0. So no worries. This one is taking because it's starting with 4. Then, regardless of the number of elements, it goes all the way to false. So it prints that out. Right? Again, a nice shortcut way, but smart. Now there's one more thing that's very interesting about this. Let me get another file. So I'm getting another called fruits. We can run that. It's got some fruits in it, about 5 of them. Now what we can do here is we looked at the range. What we can also specify is the stepping, right? How many, you want to skip anything, or you want everything in sequence, which is the default. So let me add a couple of more just to make it a little more fun. So oranges, and let's add another fruit here. Let's say grapes, right? So we got a few here. Let me rerun that. So fruit is updated. Now I want to say print fruits, and I would specify the range for this. So I want to start with, let's say, banana, which is 1, and I want to go to let's say 6 as an example, but I want to step. So when I run that without any in the step account, it will just print it out as it does, taking 1. After apple it's banana, after banana is cherries, right? So it's not skipping any. However, if I was to add 2 here, you notice the difference, that it will skip. So it starts with banana because that is the this is 0, this is index 1, and then it skips cherry because we have a step of 2. It goes to kiwi, and then it skips mango and it goes to orange, and then we run out because we don't have that many elements, right? So if we added more elements, you will see that it'll print that as well if something came after grapes. So we saw a few different ways. So to see how we can identify a certain element in that list. Okay, now we can also try and find out what is the index of a certain element, right? So we're interested to know that. I want to know, okay, mango is in that list, in the fruit list, but where is it, in positionally, where is it located? What's the index of that? So how we can do that is to say print fruits, and I use the which is index, and then I want to say, we said mango, right? So when I said that, it should tell me, let's see if we are right. So 0, 1, 2, 3, 4. So it should give me 4, which says that mango is at location 4 in this list. And if there were more than one mango, then it will print out the index of the first one it encounters. So let's say we have 2, and when I run that, it'll still give me 4 because it takes me to the first one. Now if I remove that and I rerun that, you will notice that that's updated to 6 because the one at the 4 has been dropped for some reason, right? So this gives me the position of that element. Now let's look at another one, which is finding an item, right? So I can do like a search on a certain item. So let's run this example here and I'll explain what it does. So I have something called, let's call it fruits. It's got 3 elements. If cherry is in fruit, so we're doing like an if, then say print yes, cherry is in the fruits list, right? So it'll try and find it and run that. So it was successful, so it printed. Let's say, let me make a spelling mistake here, and we don't expect it to run. So when I run that, it doesn't report anything because it doesn't find cherry, right? This cherry doesn't match this cherry. But let's say I probably made another typo and run that, and I have to make that typo here as well. That's what I'm searching for, and yes, so spelling is wrong, but what I'm trying to show is that it's actually matching. So the syntax is, this is the list, and the syntax is if this particular element is in this list, then you can print, and then so it's a convenient way to find an element in a list. Now we can also change an element, and how we can do that is, let's say I have another, I'm gonna write it here, so it should say fruits. That's what makes better sense. For numeric doesn't make sense. Okay, so again we have a list called fruits. We've got apple, banana, cherry, and now what I'm doing is I want to update. So I'm tired of eating bananas. I want to replace my diet with blackcurrant, right? So what this is actually saying is that in the list called fruits, replace the whatever is at position 1, which is 0, 1, which should be banana, and replace that with blackcurrant and print it. So let's run that, and you can see that it replaced the one at this location. Now after a few days, I got tired of cherry, right? So I want to replace that with let's say something like apples. No, I already got apples, so let's replace that with kiwi. So when I run that, you see that it's so basically what I'm doing is I can identify what I want to change and replace it with the new one, with the new element. I can also change a range. So if I have something called let's say fruits 2, it's got a bunch of elements. What I'm saying here is that change elements 1 between 1 and 3 and replace them with blackcurrant and watermelon, and when I run that, you see that I was able to, so 0, 1 and goes up to 3, which means up to 2. So replace banana and cherry with blackcurrant and watermelon, and you can see it, they just replace them in that position, right? So you can also use a range to replace. Now how do you create I'm just entering like this, but programmatically there is a way to insert additional items in the list, right? Your list is growing, right now is 6. Now you want to add all the fruits that you can think of, right? That may run into 1,000 elements. So how do we do that? We do what's called an insert. So let me just bring up the code here quickly. So you have something called fruits 2. It's got an apple, banana, cherry, and what we're saying is fruits 2 dot insert. In the second position, insert watermelon, and let's print it out. And so it just adds here. Apple and banana remain as they are in their position. You added watermelon and cherry as it is here, right? So this because we specified index 2, it came after banana and before cherry. So 0 1, you got a 2 here, cherry was pushed to the right. So imagine you're reading from a list and then inserting it into this fruits list, and you can insert and add or make that list larger. Okay, how can we join two lists? Very simple. You just have these two lists and let's join them, and it's as simple as saying add them, right? So I define another list called list 3, and I just simply add these, and you can see we created a bigger list. Now we saw that using insert we can specify an index where we want to insert, but sometimes it's easier to just append, right? Append means to the end of the of that list. So you use what is called an append command. So if I bring up the command here, so you got fruits, you got 3 items there, and then you say fruits.append orange. So what we'll do is it'll add it right after cherry. So you're not specifically saying insert in this location, you're saying just add it to the list, right? So easier. When I run that, you see that orange has been added as the last element. Now if I add another one, let's say pineapple, after that it should go after orange, right? When I run that, so it added after cherry. Okay, so let's move on to another one. Now similar to what we saw joining two lists, you can have another command which is called extend that does the same function as well. So you have fruits, you have tropical, and when you say fruits.extend, basically what's happening is fruits is tropical is being added to fruits, and then fruits become a much bigger list, right? So you have two different lists, you can add them together. Okay, and the extend method can not only cover lists, but it can also add any iterable object, whether it's tuples or sets or dictionaries. So like I said, I will create additional tutorials on tuples and sets and dictionaries, but just to know that extend can handle those as well. Now I want to remove some items, so the syntax to do that is using a command called remove, and the syntax is to specify the list, the dot remove, and then whatever you want to. So as long as this matches what is in the list, it will remove that. So when I run that, you can see that it matched banana and it removed banana from that list. So again, a convenient way is to just search, regardless, you don't have to know where that banana element is, somewhere in that list. The list could be, like I said, 10,000 elements long. So as long as you can search and it finds it, pattern matches, it will remove it. Now if we have multiple items, then let's see how remove deals with that. So what banana would do, what remove will do is we'll just go through the list, and the first one that it finds, it will remove that. So in this list you have apple, banana, cherry, banana, kiwi. So when we run this command, the first banana should in position 1, index 1 should be removed, and the rest will remain. So when I run that, you can see that the banana after apple has been removed, but the one stays. Then we have another command called pop, which basically can remove a item, but the difference is that you can specify the index. So in this case I'm specifying 1, and when I run that, it removed whatever was that index 1, which happened to be banana. Okay, and if I don't know the index, I can use pop to just remove the last element, right? So again, very convenient. I have some use case where I just want to, maybe I have a finite set of elements in a list, and once a new element enters, I want to just remove or pop the last element. So when I run that, pop will just remove the last element. So again, very very smart way to do that, and fast. Now we also have a delete or del list, which can work just like we saw in pop, that it can remove something specified at a particular index. So it removed apple here because of index 0, but the difference is that the delete or del can actually remove the list as well, right? So if we have this command and I'm saying delete this list, it will actually delete it, and when if I was to query list, it will say it does not define as not listed. And then let's see if I run it in print, what does it give me? So same error, it's not there because we just removed or deleted it. Now this is different from what is called clear, which can just clear the list, right, of any elements. So if I have something called this list, I create another one and I say dot clear, it will clear the elements but not delete the list. So when I run that, you can see now I got an empty list, right? So notice the difference between clear and del or delete. Now we can also loop through using like a for loop. So let's have a quick example of how we can do that. And so I have a list called apple, banana, cherry, and I can say for x in this list, print x. So this I can choose anything, right? But it just circles through each element and just prints it out. So very nifty way of printing out the list. So like I said, I can give it any name. I can give it fruit, but then I have to say fruit. So it's just like a temporary naming, right? So the same result. So I can say for a in this list, print a, right? So it just goes to the first, second, third, all the elements, and just prints them out. I can also use the index number, and it's a smart way of getting it. We already learned about length. So I have this list. What I'm saying is for I in range, and get me the length. So when it run it, gets the length of that list, and then it just cycles through all the elements based on the indexing. So very similar result to this one, but in this case we are actually doing additional work of first calculating or getting the total size of the list, and then saying to for, say for in this range from, let's say, 0 to 100, 0 to 10. Just go through and print out everything that you find. We can also use the while command. So very similar syntax. So we start, make sure I is 0, and while I is less than the length of this find. Again, we're very smart way of using the length to calculate the number, and I print it out, and I also need to increment, so it goes to the next one, and when I run that, very similar result. So use of for or while it's up to you how you use it. It also sometimes depend on how you're programming, but this command is available to you. Okay, let's see, what else do we have. Let's look at something that is called list comprehension, and it's a more compressed way of printing. So if I say okay, and if I print this, so this is I'm doing it using the standard for X and fruits, matching, and then appending using the append command. But if I was using list comprehension and using the same list called fruits, it's so much more compact. I just define a new list which is X for X, and again this X you can use, it can be A for A, I for I, doesn't matter, in fruits, so it will match each element. And if any of them has an A, print that, right? So when I run that and I do print the new list, it will print only those which have contain an A. So apple, banana, cherry, and mango contain that, so it printed that out, right? So very similar to this, but as you can see, this is about 4 lines, a little more involved, while using list comprehension is much more easier to read and more compact, so better programming. So this is a pretty nice way to also calculate different things. So let me say I have a new list and I want to print all the numbers till 100 as long as they're less than 55. So when I run that and I say print this new list, I get all the numbers up to 54, right? Because it's less than 55. So different examples. I can also use, let's say I have something called Fibonacci numbers, and I want to iterate through this, right? So let me do that. Let me change that to Fibonacci. Oh, sorry, my mistake. That's the new one that we are. So some numbers. So it's just going to go through each of the numbers, and so we got. Oops, sorry, my mistake. Should be enclosed in parentheses, right? And then you can see that it just printed those numbers, right? Now I just want to find out the ones that are in this list that are even numbers. So I want to create a new list out of these. So I'm using list comprehension, so I'm going through each number and I'm doing like a condition, so saying if that number modu 2 equals 0, which means it divides completely, there's no remainder, then print those even numbers. So it's going to go through that list, and you notice that it printed 2, 8 and 34, which are the 3 even numbers in this list. Using this so using the list comprehension makes it very compact and easy to read. Similarly, I can do it for let's say odd numbers, right? So I have this code. The only difference is that I'm saying num modulo 2 is not equal to 0, right? Because when you divide a number by the odd number, it should leave a like remainder. So these are all the odd numbers, right? So very easy way to do that. One before we just wrap up this part, quick way to use some list comprehension to change all these elements into like uppercase, as an example. So when we print new list, you see all of them have changed to uppercase. Let's have another example of using list comprehension. So I want to square each number that is in the Fibonacci numbers list. So the syntax is number to the power 2 for each number in, and when I print that, I get a square of all the numbers in this list that we saw here, the Fibonacci. And if I do, like, I want to find the cubes, so when I run that, I get cubes of all these Fibonacci numbers. So that was I know it got a little long, but I did wanted to cover list in detail because it's really easy to understand, and best of all, you probably saw how powerful it was, and there are so many ways to solve different problems. So I really hope that you enjoyed this tutorial on lists, and I hope to create more in list related elements, which is sets and tuples and dictionaries. So stay tuned, and thank you very much for watching.